beginning. Yeah. So only host can present. Wait. Host can share screen. Okay. Wait. Okay. Can see the white screen.
Yeah.
Yeah. Still some of you joining the class. Okay. I just want to repeat what I taught you last week so that today you can follow it. Okay. Who did this? Wait, still some of you asking to join. Don't write anything on the board. Okay. I think we can start now. Okay. Okay. Oh, still just asking. Okay. First one is for the 3.1, we need to go through what is mean by electromagnet. So I already explained to you what is mean by. Okay. So what is mean by electromagnet? So what is mean by electromagnet? What I tell you, it's a temporary magnet. Yeah, temporary magnet. So when current flow, it will be the soft iron core will be magnetized. When current is disconnected, the soft iron core will be demagnetized. Yeah. So I don't want to repeat this. Okay. So now we go through. Let's say there is a cardboard, and now there is a. Sorry, I go a bit fast. Yeah, a bit fast because we already finished last week. Okay, when there is a current flow in this conductor, in which direction is the current flow? Current flow from here, right, in this direction. So from here is flowing out to the surface. So when it's flowing out to the surface, what happens? Surrounding this conductor, it will produce what? Magnetic field. So the direction of the magnetic field we can identify using a rule. We call it as right hand grip rule. So in which direction these compasses will deflect? So we use the right hand grip rule where your thumb will point to what direction of the current. And then when you curl the fingers, it will show what direction of the magnetic field. So based on that, in which direction it will deflect? This one will be what? Downward. This one to the right. And this one will be upward. Okay. Oh, sorry, it's not clear. Yeah. Okay. Okay. So here it will be downward. Here will be to the right. And then it will be what? Here upward. Okay. And then okay. If you want to draw the pattern of the magnetic field, okay, pattern will be current. If upward, we have to put what? We have to put dot. So the dot over here indicates what? Current is out of the surface. Okay, current is out of the surface. And then we draw the magnetic. Can I draw a bit fast? Okay. So what happened? Direction of magnetic field will be what? In the anti-clockwise direction. Okay. Sorry, I'm going fast. So drawing is not nice. Okay. So first case. Second case is if let's say if the direction of the current is reversed. Okay. If we change the terminals of the battery. Okay. Terminals of the battery. Okay, here compass 1, compass 2, compass 3. Now current is flowing where? From upward to downward. So if flow downward, so direction we can determine using right hand grip rule. So here it will be deflect downward, here deflect to the left, here deflect upward. So you can see the direction change. And then if you want to draw the pattern of the magnetic field, so if current is in, we have to put what? Cross. The cross shows what? Current is into the magnetic, so into the surface, yeah? Into the surface, and then we draw the magnetic field clockwise or anti-clockwise. It will be in the clockwise direction. Okay, sorry, it's not nice drawing. Okay, so this one for the pattern of the magnetic field that formed by a straight conductor that conducting current. Okay, a conductor that conducting current. Okay, then the next one is a coil. Okay, for a coil, yeah? When a coil conducting current. Okay, when a coil conducting current, okay, let's say this is a surface, and then there is a conductor conducting current. Okay, coil, yeah? Coil. Oh, sorry. Slippery. Okay, it is a coil that conducting current. So here is a battery, current flowing. Where is the current flowing? Current flow on the left hand side is upward, and then go to the right hand side, it is inward. Okay, it will be inward. So how about the direction of deflection of the compasses over here? Let's say here one compass, here one compass, here one more. So how to identify? So we have to use the same rules, right hand grip rule. Okay, before that, you look at the left hand side, yeah? Left hand side. Okay, on the left hand side, current is what? Flowing upward. Okay, current is flowing upward. So we have to put, who is drawing? Okay, thank you. So here current is flowing upward. On the left hand side, we put dot. On the right hand side, we put current is in, we have to put cross. Okay, we have to put cross. Okay, so on the left hand side, because of current is out of the surface, so you will see the magnetic fields which is in the, we need to start the story from here, yeah? Oh, sorry, not nice circle. A whiteboard, okay. Okay, so current flowing is into the surface, then the magnetic field will be in the, oh sorry, it will be in the anti-clockwise. Oh, delete.
对啊，那要摸什么吗？
Yes.
你要摸什么吗？哦，他摸到我在巴萨，然后被一群人围住了。早上不要吃比较好吗？早上吃会疯嘛。
Oh, we can hear you.
Sir, don't mute yourself. Mute other people, not yourself.
Okay, thank you. Now, okay, right? Okay, sorry, yeah, because it's now really mute all of you together. So if you look at the center, what happened is what? It's the same direction. Okay, it's the same direction. So the resultant magnetic field, okay, that means the combination here, the combination of the both magnetic fields will be like this. So here we put dot on the left hand side. So current is what? Out of the surface. And then on the right hand side is what? Current is into the surface. So because the center, it is in the same direction. So we have to draw a straight line. Okay. Then here we draw a curved line. Sorry, the screen is very smooth. That's why it's not nice curve. Okay. Then so it will be what? Center will be same direction. So this is a pattern of the magnetic field that will be formed. Okay, and then what got one more here? One more is regarding the force acting. So I don't want to teach the force acting over here now. So this is the pattern of the magnetic field that will be formed. Okay. Okay. So now we go for the another one. This one for the coil. Now we come to the solenoid. So I don't want to repeat everything from the solenoid, just only one. Okay, let's say. Okay, I place soft iron core. Okay, if I place a soft iron core, what happened? Okay, and then one more is if I wind the wire. Okay, if I wind the wire on this core, what happened? Current is flowing. When current is flowing, what happened now? In which direction the current is flowing? So current is flowing as given like this, right? In this direction. So when the current is flowing as given, what happened? One of the end become north pole, one more end become south pole. Which end is the north pole? So you have to use what? Please use right hand grip rule, but your thumb will point what? Direction north pole. Curl the fingers. The four fingers will show what? Direction of the direction of current. Is it okay? You want me to draw on the whiteboard or here? Which one is better for this one? Because I need to show the rules.
Whiteboard, sir.
Whiteboard lah.
Whiteboard, eh? Okay, then I stop this presentation, eh?
Okay.
Okay, because this one just want to repeat. That's why I draw over here. Okay, so I move to whiteboard. Okay, wait. Okay, for a solenoid, yeah, okay, for a solenoid. Oh, here one more waiting. Okay, so let's say here is a solenoid, and then we wind the coil. Nice. And this one I bring to the front. You want to draw too many solid coils over here, and then here is a battery. Okay, is a battery where here will be positive terminal, here will be negative terminal. So current flowing as given, right, in this direction. So we draw at the front. So when the current is flowing as given, what happens is what? One of the end become north pole, one more end become south pole. So which end become north pole, which end become south pole? So we have to use what? We want to use the technique that I showed you last week. Stand from here and then check and then on top. So the one will be disturbing, confused. So what we need to use, what you have to use the right hand grip rule. So the four fingers over here, follow the direction of the current. So it is what in front to the right. Then your thumb will point what? Direction of the current. So direction of the pole, north pole. So here will be north, over here will be what? South. Okay, north and one more what? South. And then one more, if let's say if the way I want, okay, all the terminals of the battery I change. Okay, the terminals of the battery I change. So here it is positive, here is what? Negative. So what happened now? Current flowing, yes, current flowing, which direction? So here, it is flowing to the left. Okay, it is flowing to the left. So it's flowing to the left, what happened? Let's check using the right hand grip rule. Okay, your 4 fingers over here. Okay, 4 fingers right hand. Okay, follow the arrow, follow the arrow. It's in front to the left. Okay, curl to the left. Follow the arrow. Follow the arrow. So it is to the left where your thumb points. Your thumb points downward. Then here is North Pole. Here will be South Pole. Okay, so this is a way to identify the poles. And the next is, okay, let's say it's produced an electromagnet, that is temporary magnet. Whatever, it produces the magnetic fields like this. Okay, it will produce the magnetic fields away from north. Here is the North Pole. Okay, here will be the South Pole, away from north and towards the south. So it will produce magnetic fields like this. But anyway, if you want to produce a strong electromagnet, okay, or weak, how to identify weak? So let's say if I give you two soft iron cores over here. One. Okay, here we got two soft iron cores. Yeah? I don't want to wind so many turns of coils on this soft iron core. Okay. Okay, let's say here got a battery. Okay, battery. And then, okay, one more. Before we continue, you go to the participants column. Please swipe your name to the left and rename here if you are not using your actual name. Okay, if you are sharing for what, okay, please rename. Okay, so now let's say over here, I bring the wire to the right hand side. I wind on this soft iron core. These two soft iron core. Okay, only 3 turns of coils over here. Okay. I told already. Gayatri, are you in the group? Okay, so now I'll rewind the coils on these two soft iron core as given. You see over here, important is what? Over here, the wire goes to the back, come to the back. For the second iron core, what? Same, okay, at the back. Both is, okay, on the same side, I mean at the back, yeah? Okay, so now we check the flow of current. Where's the current flow? Current flow as given, that is, and then come to the coil. Over here it is going down, then here it is what? Upward. Okay, it is upward, then again here goes down, come over here, it is upward. You must know how to draw and also label to produce. I mean, draw and then wind the wires so that it can produce stronger electromagnet. Okay. So now we identify the poles. Which side is north pole and which side is south pole? Let's check. Okay, here current is flowing. Where is it? Upward. Okay, we check the first one. The first soft iron core. Current is flowing where? Can you see it now? Over here, current is flowing upward. Upward. Please use right angle rule. Okay, for the first, I show you. Plus. Plus. Okay. Okay, look at the first soft iron. Okay, first soft iron core, what happened? You use the right hand, current over here flowing upward. Okay, it is upward. Then follow the arrow, upward. So your thumb points to the left. That means what happened? Here will be north, over here will be south. So we label. Okay, over here will be north, over here will be south. Okay, one of the end become north pole and one more end become south pole. Okay, now we go for the second core. Okay, for the second core, okay, here I close. Okay, I close over here. Then over here, what happened? Current is flowing where? Upward. It is flowing upward. Where your thumb? Again, here current flowing upward. Your thumb points to the left. Here will be what? North pole. So here will be north pole. Over here will be south pole. So now you can see at the end over here, south and south. They mean like poles. If like poles, we know that it will repel. So if repel, the magnetic field will be what? Away. So it won't produce a strong electromagnet. I mean over here, the magnetic field getting what? Weaker. It produces very weak electromagnet because it produces like poles. So it is not suitable. If you wind as given over here, it won't produce a stronger electromagnet. It is a very big electromagnet. But now, how are you going to produce a strong electromagnet? How? Okay, to produce strong electromagnet, I draw one more diagram. Okay, same like just now. And then the first wire, 1, 2, 3. Okay, first one still same as here. First one. And then when you come to the second core, when you're going to wind the wire on the second core, very easy. If you just check this section only, you know already whether it will produce a strong electromagnet or not. Yeah. So here it is going to the back, right? To the back. Yeah. You wind the wire at the back, and then come to the second core. Here you pull to the front. Okay, come to the front. Then goes up. Okay, so I rewind the wires like this. Now we check the direction of the current flow. Okay, where is the current flow? Which direction? Okay, let's check. Okay, here positive, here negative, same. Battery terminals or battery is the same. So current flowing. Come to the first core, it is upward. Upward. Second core, okay, going to the down, backward. Come over here, it is what? Downward. Okay, now let's check the poles. Let's check the poles. Which side become north and which side become south? Okay, which side become north and which side become south pole? Okay, so the poles. Okay, so same like just now. We check the first core. Here, current upward. Upward. Your thumb points to the left. So north pole will be on your right. Here will be, so on the left. North pole will be on the left. If you check, north pole on the left and south pole on the right. Then come to second core. Where is the poles? Okay, here current is moving downward, correct? Okay, come to the front, in front, right, in front, downward, and then your thumb points to the right. Okay, check again. Current in front, downward. Yeah, so see the 4 fingers over here. Follow the direction of the current, and then your thumb points to the right. So here will be north pole. Here will be south pole. Okay, one of the end become north, one more end become south pole. Okay, so how about here? So now at the end over here become what? Unlike poles. If become unlike poles, so the pattern of the magnetic fields will be like this. Here, straight. What happened? Now the magnetic fields is focus, right? Concentrated. This is the magnetic field that will be formed. So it will produce what? It produce strong electromagnet. Yeah. So it will produce strong electromagnet. How to identify whether it's a strong electromagnet or not? How to identify? We check over here. Here is going to the back. Come to here, come to the front, right? So we just check at these two sections. We know really whether it will become a strong electromagnet or not. So at the end over here only, here going to the back, here come to the front. Enough. We can identify. Okay. So the end over here is become unlike poles. Then what? It can concentrate the magnetic fields. Okay. Okay, one more that they can ask in the exam, the shape of the iron core that you're going to use. The shape. Okay, this one sample. Now I'm going to show you the shape of the iron core. Okay, what shape is this? C. Correct? It is what? C shape. Or if you place like this, it is what? N shape. Correct? Or if you place like this, it will become what? U shape. So you can say in the exam, U shape, N shape, or C shape. Right? So anything can. Okay. So later I tell you the shape. And then next is the way you're going to wind the wires. So that we have to wind the wires. Where the sound comes from. Okay. So current flow here upward, come to here, it is flowing downward. Okay, one side is upward, one side is downward. So what happened now? Same as the same. See, the solid side still the same. So here become what? South, or here become north, here become north, and here become what? South. So what happened over here? At the end over here, it will produce what? Strong electromagnet. So the magnetic field will be what? Concentrated. Yeah, it will be concentrated, north to south. So if in the exam they ask you one of the characteristics, yeah, one of the characteristics, Wen Shao Zi, who is this? From Taman Selase, I think. Okay, ask him to update his Zoom. For the safety purpose, they keep on update the Zoom app. So you also have to just update very fast. So please contact, and if anyone knows there, Wen Shao Zi, ask this student to update his Zoom, then only come back to the group again. Okay, so the shape over here, we can say C or U or N. Okay, with U shape, C shape, N shape. Yeah. Or we also can say it as what? Horseshoe. Okay. Okay. Horseshoe shape. Wait, I need to message.
The group get
Okay. Okay. So this shape that we want. So remember, you can write U shape, N shape, C shape, or you can write horseshoe. Horseshoe is what? Ladang kuda. Okay. So why we have to choose this shape? So that produce stronger electromagnet. Okay, so that it can produce what? Stronger electromagnet. So in terms of shape, you need to know. Wen Shao Zi. Okay. Wen Shao Zi, are you in the group? Yes, you're in the group. Okay. So, finish. Okay, now we are going to go through what are the factors. What are the factors that can make this electromagnet become a stronger electromagnet? So now we are going to go through factors affecting strength of an electromagnet. Okay, factors that are affecting strength of an electromagnet. Number 1, 2, 3. Okay, the factor number 1, actually you can do this experiment in school, very simple experiment. Easiest, and they will ask a few times in SPM. Yeah. So the first one is current. Electric current. The current that flow. Okay, the current that flow. I think how many? I don't know which year, but they asked. Oh, sorry, SPM 2010. Yeah, they asked 2010. and plus one more here. If not mistaken, 2016. Yeah, they ask this. And one more is number of turns of coils. Second one is number of turns of coils. So we use N capital letter and units if numbers. If it refers to numbers, we use what? N, yeah? N, number of turns. And then the third one is type of core. Okay, type of core. So if they ask type of core, okay, they ask type of core, remember, type of core, it is not a physical quantity. So we cannot write this as a variable for experiment. Remember, cannot be written as a variable. Manipulated variable, responding variable, or constant variable. So we cannot write type. Type is, it is not accepted. Yeah? Okay, so type of core, if they ask, maybe they can ask you in structure or essay or objective. Remember this core, it's the most suitable is soft iron core. They can give you one mark. If let's say you're going to choose what type of core you're going to choose to make an electromagnet. So let's say you want to write copper core, aluminum core, okay, iron core. So answer is what? Iron core. Yeah. So we choose soft iron core. 1 mark will be given. Why we have to choose soft iron? So last week I show you the steel, right? This one is what? Stainless steel. When current flow, it is okay. It is magnetized. It attracts the needles. But when I disconnect the current, what happens? Still, some of the needles are attracted to the core. So they mean it is not good electromagnet. This is what? Stainless steel. Okay, it is stainless steel. So we have to choose iron, soft iron core. Okay. Why we have to choose soft iron core? The reason, because it is easily magnetized and demagnetized. Okay, because of it is easily magnetized and demagnetized. Okay, it is easily magnetized and demagnetized. Okay, now we are going to go through the experiment. So we got 2 experiments. We go through both because for past a few years, experiment that came out from from 5 syllabus, from chapter 2 and chapter 3 only. Chapter 1, yes, got, but they didn't ask for so long. I think they asked last year is 2013. After that, no practical question from chapter 1 wave. Chapter 2, chapter 3, I mean 2014, 15, 16, 17, 18, 19. 6 years already, they didn't ask experiment from chapter wave. I mean, all the experiment came out from chapter 2 and chapter 3 from form 5. Okay, so now, okay, so now we are going to go through experiment. I'm not going to give you a complete report now. Here, I start with variables. I go through the arrangement, and then the rest you have to do on your own. Yeah, but you have to go a bit fast. Okay, let's go through experiment. We want to find the relationship between current I and strength of electromagnet. Okay, strength of electromagnet. Okay, so as normal, A, B, C1. Leave it A, B, C1. So we start with C2. C2 is, you leave 2 lines, 2 lines, 2 lines. Leave 2 each for each. A is for inference. B is hypothesis. C1 is in. So we start the story from C2. C2 is a variable. Manipulated variable. corresponding variable, and constant variable. But in the exam, please don't use a short form. F dot B, write full. Manipulated variable, corresponding variable, and constant variable. Okay, so manipulated variable is current ampere. Corresponding variable is the wait data I give you. You can take note first. Number of needles attracted. So I use small letter n. Number of needles attracted. You don't the number of needles, you can write number of pins attracted. Okay, number of needles attracted or number of pins attracted. Okay. And then for the constant variable, so we choose this number of turns of coins. So I use n only for the numbers. Yeah? Numbers, I use letter n. Number of needles attracted, I use small letter. And here number of turns of coins, I use capital letter. So you want to switch also, you can get symbol. Symbol can be switched, no problem. Okay. Number 3 is the materials and apparatus. All right. So wait, later I give you the materials and apparatus. It's very easy. Okay, we go for number 4. Okay, number 4. Okay, this is what symbol for battery. You don't use battery. We can change to DC power supply because battery is a direct current supply. So we want to write DC power supply also as a separate. DC power supply. You just put this and then write DC power supply also. Okay, no problem. Okay. And then over here we place a battery dish, and then inside we place some needles. Okay, you label later. Okay, it's needles. Then this is what? Soft iron core. Okay, soft iron core. And then the next is insulated copper wire. Okay, insulated copper wire. And this one you label as rheostat, ammeter, battery, or you can write DC power supply. Don't write AC. DC power supply. D.C. Yeah? DC power supply. Okay, draw first. Must know how to draw. Okay, already draw. Please there practice. Okay, so today we come to number 5 is procedure. Okay, leave about 6 to 7 lines. Okay, leave 6 to 7 lines. Then we go for number 6 and also number 7. Okay, 6, I think all of you know, is a table. We come out with 2 columns and we use symbol given over here. Manipulated variable is what? I, ampere, and then responding variable is, okay, I use small letter N and write units. Okay, 1, 2, 3, 4, 5, and then here will be the labeling the variables correctly. So here we write I ampere, and here we write N units. No need to plot the graph. Can you see or not? Can you see the full screen? Yeah, check here.
Yes, sir.
Can I? Why my iPad cannot see complete? Oh, okay. Sorry. Okay. And then here we write 0.2, 0.3, 0.4, 0.5, 0.6. Oh, 0.1 also can, no problem. Or you want to write 1, 2, 3, 4, 5 ampere also can, no problem. But 1 ampere considered is very high current. So we'll start with a small value. Okay, so the last one is okay. Number 6, C, number 6 is tabulation of data. Please come on symbol unit, and make sure that you already give the symbols in the variable. Then you use the symbol in the table and also in the graph. Please do like this. Okay, done. Okay, now remember here, when the number of needles or pins, or you can write thumbtack or anything here, number of needles affected. The number of needles affected when become more, it shows what? The electromagnet getting what? Stronger. Okay, when the number of needles attracted is more, it produces a strong electromagnet. So we are not going to use the word strength of electromagnet all the while. Yeah? So you write first one, number of, you want to write based on the variables, can, no problem. Or you want to write strength of electromagnet depends on current flow. Or you want to write number of needles attracted depends on current. Okay, right? First, number for the A, yeah? Number of needles attracted. Number of needles attracted depends on current. A, finish. Then we go for the B. For the B, when current increase, number of needles attracted also increase. Please write based on experiment. Okay, when current increase, number of needles attracted also increase. When current increase, number of needles attracted also increase. When current increase, number of needles attracted also increase. Then for the C1, to investigate the relationship between of electromagnet. Plus. Okay. To investigate the relationship between current and number of needles attracted. This experiment consists very simple experiment. Yeah, very simple. Okay, now in the list of materials apparatus, please write insulated copper wire, soft iron core, needles, rheostat, DC power supply or battery, emitter, and also connecting wires. Don't miss this. Connecting wires. DC power supply. Okay, DC power supply. Or you don't want DC power supply? You label battery also can. Okay, battery also can, no problem. Okay, so now we go for the procedure. Okay, for the procedure. Ready? So the procedure over here, it must be functioning. It must be functioning. So the first one, you write, okay, arrange the materials as shown in the figure above. Okay, you want to write, it's no problem, but no mark to be given for that. So what you can do is, okay, switch on the circuit. First one, you write here, write this first. Switch on. Okay, switch on the circuit. Switch on the circuit. And the next is continue. Adjust the rheostat until current flow become 0. How much we are using? 0.2 until 0.2 ampere. Adjust the rheostat until current flow becomes 0.2 ampere. Okay, adjust the rheostat until current flow becomes 0.2 ampere. Okay, adjust the rheostat until current flow becomes 0.2 ampere. Okay, the next one, sorry, not enough space. You already adjust current flow is what? 0.2 ampere. Okay, then next one you write touch the needles with soft iron core. Touch the needles soft iron core and please write here, one more later I tell you. Touch the needles with soft iron core and touch the needles with soft iron core and record number of needles attracted. Record or count also can record or count number of needles attracted. Record or count number of needles attracted. Record or count number of needles attracted. Okay, touch the needles with soft iron core and record the number of needles attracted. Then the last one, repetition. So you have to tell another 4. So repeat the procedure above. Repeat the procedure above. The last point here. Repeat the procedure above using currents of 0.3 ampere, 0.4 ampere, 0.5 ampere, and 0.6 ampere. Another 4 new values. So I repeat the procedure above using currents of 0.3 ampere, 0.4 ampere, 0.5 ampere, and 0.6 ampere. Okay? Finish? So the famous experiment, so many times they ask this. And now we are going to go through another experiment. Complete, yeah? Complete. I will give you a complete experiment without data, which can be asked as a question number 4 in paper 3. And one more, I forgot to tell you, you are going to sit for the mid-year exam in July. You're going to sit for the mid-year exam in July. So next month will be your exam. Okay, so finish. Now we go for the second experiment, experiment number 2. We have to find the relationship between, okay, we go for the number of turns. I think 2018. The students didn't check the diagram carefully. Okay, in the diagram they will give number of magnets. Actually, they want for subtopic number 3. Okay, so what you learn over here, please try to differentiate. You must differentiate, okay, the strength of electromagnet with the subtopic number 3 that you're going to study later. Sometimes students will confuse. They cannot differentiate. Like subtopic number 1 or subtopic number 2 or subtopic number 3. So be careful. So for the second experiment, you want to find the relationship between number of turns of coils and strength of electromagnet. Number of turns of coils and strength of electromagnet. Okay, number of turns of coils and strength of electromagnet. Okay, so here very simple. Number of turns of coils and then current we switch. So here we write current I ampere, and then many variable we write number of turns of coils and and capital letter, and units. So here you can see I wind about 4. You can count. I wind over here 2, 4, 6, 8, 10 turns only. Only 10 turns. If I go for, let's say, 20 turns, 30 turns, 40 and 50 turns of coils over here, solenoids here, in terms of coils, number of turns of coil, and then if you, after you let the current flow and then touch the needles, you can see it will attract more needles. It shows what? It becomes strong electromagnet. So, okay, let's rewrite the first one. First one, inference. Right first, right. It's very simple. Just need to switch only. Okay. Number of needles for the A Number of needles attracted depends on number of turns of coil. Number of needles attracted depends on number of turns of coils. Number of needles attracted depends on number of turns of coils. Okay, number of needles attracted depends on number of turns of coils. Okay, number of turns of coil, number of needles attracted depends on number of turns of coil. Or you want right? The strength of electromagnet depends on number of turns of coil. Only for the inference. Only for the inference. Number of the strength of electromagnet depends on number of turns of coils. Strength of electromagnet depends on number of turns of coils. Okay, then for the B onward must base on the experiment. Okay, must base on the experiment. So for the B, when number of turns of coils increase, when number of turns of coils increase, I'll give you time, you can write first. Right. When number of turns of coils increase, when number of turns of coils increase, the number of needles attracted also increase. The number of needles attracted also increase. The number of needles attracted also increase. Okay, the number of needles attracted also increase. Okay, for the C1, when number of turns of coils increase, number of needles attracted also increase. When the number of turns of coils increase, number of needles attracted also increase. Number of needles attracted also increase. So for the first three, actually is bonus for you if you know the variable. Okay, now you copy until number 4 until the diagram. Until here is still the same, no change. Okay, until number 4. Faster, I'll give you 2 minutes. Complete. Copy number 2, 3, 4, and also label the diagram. Minimum 3 of the materials and apparatus must be labeled. Durgashini, are you just joined the class? You just joined the class? No answer. You don't send me the message through the chat box. I cannot see. Okay. Finish. Okay, now come to the table and then procedure we can complete later. Okay, for the table, many variables what? Number of turns of coils. So here we write N. I use capital letter N units. Whether you can see or not. N units. Okay, units. And here we use small letter n to represent number of needles attracted. Okay, number of needles attracted. We are using small letter N. You have to switch this again, but if you switch, you have to make that. Here also, you have to switch it. Okay. And then table finish. We come to the graph. Here we write and and units, calculator to represent the number of turns of coil. Many variable must be on the x-axis. Corresponding variable on the y-axis. Okay, procedure only, leave it first. Okay, then the number of turns of coils, 10, 20, 30, 40, 50. Or you want to write 20, 40, 60, 80, 100 also can. Oh, 100, 200, 300, 400, 500 also can, no problem. No problem. Okay, now we come to the procedure. Complete the last two, then towards the end only you write the procedure. Okay, easy. Okay, procedure. Get ready? Okay, so for the procedure, I tell you, okay, please write. Okay, for the procedure, switch on the circuit. Oh, sorry. Before switch on, you need to tell how many turns of coil that you're going to use. Okay, how many turns of coil that you're going to use. So here we write Y. Y means what? Lily. Okay, Y. 10 turns of insulated copper wire on the soft iron core. Why 10 turns of insulated copper wire on the soft iron core? Okay, why 10 turns of why 10 turns of insulated copper wire on the soft iron core? Then after that, you have to tell, switch on the circuit. Then only what? It is functioning. We just adjust the rheostat, but without switch, switch on the circuit, no function. So, switch on the circuit. And adjust the rheostat until current flow become 0.5 ampere, but no marks for 0.5 because this is not manipulated variable. Yeah. So adjust the circuit and switch on the circuit and adjust the rheostat until the current flow becomes 0.5 ampere. Okay. So only one more given for this, for the number of turns. 10 turns of insulated copper wire. They give 1 mark for the procedure because you already control the first value of the manipulated variable. Okay, the next one, please write. Not enough space to write. So you write, I tell you. You already switch on, right? And adjust the current. Okay. Touch the needles. You can repeat the previous one. Touch the needles with the soft iron core. Touch the needles with 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 soft iron core. And record. And record number of needles attracted. And record number of needles attracted. Touch, okay. Touch the needles with soft iron core. And record number of needles attracted. Okay. Then the next one is what? The last one, repeat. Repeat the procedure above. Repeat the procedure above. Repeat the procedure above. Repeat the procedure above. Using currents of. Using currents of. Using currents of. Sorry. Repeat the procedure above using. Sorry, using 20 turns, 30 turns, 40 turns, and 50 turns. I repeat, repeat the procedure above using 20 turns, 30 turns, 40 turns, and 50 turns of insulated copper wire. Repeat the procedure above using 20 turns, 30 turns, 40 turns, and 50 turns of copper, insulated copper wire. I send the file first. Okay, finish. Wait, I take this file. Where is it? Application. So send to create a new note. Import. Done. Wait, I check here. Paste the notes. Okay. Paste the notes. Hold on, I checking the file where I miss. Where is this? Button hit electronic applications. Reasons. Applications. Okay. Hold on, where? Oh, okay, here.
Sir,
Yeah, coming, wait.
the C1 not aim.
Yeah, C1 is aim to investigate the relationship between number of turns of coils and number of needles affected.
Oh, okay. Thank you, sir.
It's already fixed. A inference, B hypothesis, C1 is aim. It's already fixed. So this is one that we are studying since last year. Okay. So we already finished until the experiments. So we got 2 experiments over here, and both experiments that we test in SPM, each twice in SPM, twice. So now we are going to go through applications of electromagnet. So this one I have to present here. Okay, I'm going to present now. Finish already? You finish. Let's check the presentation. Okay, the last part of this subtopic is applications of electromagnet. Application means in which situations that we are using electromagnet. That means it's a temporary magnet. When current flow, it is magnetized. When current flow, it will lose the electromagnets immediately. So we are going to go through some of it. So let's check. If you want to screenshot later, can, no problem. Okay. Okay. Consider, wait, anyone asking here? No. Okay, good. Okay, applications of electromagnet. Okay, applications of electromagnet. Okay, large electromagnets is what temporary magnet, yeah, are used for lifting heavy iron objects. Okay, small ones are used in various electrical devices such as electric bell that we are going to go through later. Electric bell. Also, they test this as a essay question in SPM. Electric bell, telephones, loudspeaker. Okay, and also got more. Later we go through like circuit breaker. Okay, the advantage of using the soft iron core to make an electromagnet is that the magnetic effect of the soft iron disappears immediately. That means what? When no current flow, what happened? The magnet, it will lose the effect of magnetism immediately. It lost. Okay, when no current flows, disappears immediately. When no current flows. Okay, so example. Okay, if you look at this is what we call scrap lifting magnet. Okay, or lifting electromagnet. Also can be the essay question exam. They will give you a few crane, for example, crane. Yeah, for example, yeah, I draw this. Okay, when I say first one, I show you here is a scrap lifting magnet. We are using what? Crane, yeah, crane. Okay, so when the current flow, when the current, don't draw this, yeah. When current flow is attract what? Lot of metals. Okay, and then when second one, this one when current flow, but okay, when the current is switched off. Okay, when the current is switched off. Okay, let's say this is a electromagnet after the current is switched off. Okay, here is a crane. Okay, when the current is switched off, let's say still some of the metals still attached, still attracted. Okay, that means it is not a good electromagnet. Why? Because it cannot lose its magnetism. So don't choose this. Let's say this is the arrangement P. And then let's say they give you Q. Okay, let's say Q, they say, okay. Now later I remove this, yeah? Just idea only. Want to get the idea. Can see, right? Okay, can see. Okay, good. Okay, so here, let's say it's attract more. Very good, very good. And here it is not dropping. Everything remains. So also it's not a good electromagnet. If you want to choose, let's say it's on Q, and then we go for the R. So make sure that when current flow, it attracts more metals. Good. And then when no current flow, it can all the what you call the metals must drop. Then you choose that. I mean here P and Q is not suitable because of what? Because when current flow is attract, okay, good. But after current is disconnected, it does not attract, still affect the metals. So it's not a good electromagnet. If can, all must drop. And also they can ask you in terms of, for example, inside they show you the cross section. Okay, inside. Okay, wait. Let's say they show you, they will come up with a cross section. Okay, then they will show you. Okay, inside got coils. Oh, got more turns of coil. Here a few turns. Here few turns. So we have to choose more turns of coils. Why? can produce a strong electromagnet. And also they can ask you what type of coil you're going to choose. Steel, aluminium, copper. Which one? Iron. We have to choose what? Iron, soft iron core. Why? Easily magnetized and demagnetized. Okay, this one also can be asked as a question, but they won't ask you in terms of explanation. Don't worry. Okay, maybe they can ask you, how about the current? How about the current? High current. Why? Produce stronger electromagnet. And then how about number of turns of coil? Increase number of turns of coil. Produce stronger electromagnet. Rutresh, off your mic. Thank you. Okay. Okay, increase number of turns of coils. Why? Produce stronger electromagnet. And then what type of coil you're going to choose? We choose what? Soft iron core. Why soft iron core? Easily magnetized and demagnetized. So these are the points. These are the points. They won't ask you to explain, don't worry. Can get the idea or not? So I think I can remove this, yeah? I can remove this. Don't worry. They won't ask you to explain. It's very easy to answer. Later you see all these aspects coming back. Okay. So they won't ask you to explain all this. Okay. Lifting electromagnet. So idea is very simple. When the current is flowing, what happened inside over here? Got what? Coils. They wind the coil on the soft iron core. What happened? The soft iron core magnetized and then it will attract the metals. When the current over here is switched off, what happened? The soft iron core inside will lose the magnetism. It will be demagnetized. All the metals will drop. Okay, so simple. Don't worry about the working principle. The one. But we must know that in this lifting electromagnet, they are using soft iron core and also the coils. Okay, so lifting electromagnet is not a problem. Okay, we come out with a electric bell. Wait, electric bell. Wait, I need to stop for a while. Wait. Wait. Share using this other app. Kavin Arasan. Wait, I need to open the PowerPoint. PDF PowerPoint. Open. Yeah. OneDrive. Basics. Okay. Hold on, I'm checking the file. Where is the file? Wait. Forms. Hold on, Hold on. Wait, mic is on, In which file? I'm opening it. PowerPoint. Attachment.
What is this?
PowerPoint. Wait. So I saved the file
On my iPad?
on my iPad.
Not now.
iPad inbox. Is here.
Jadi again.
Hold on, hold on. Okay, done. Okay, now we go for PowerPoint, slideshow from start. Okay, now clear, eh? Right? What happened? Okay. Okay. Hold on, huh? Wait. It's a presentation.
Where to tekan lagi? Because
No, yes.
this one is the worst.
Wait, screen share.
No. Make us host.
Hold on, huh? It's not can. Okay. What happened?
Stop presenting.
I got mark here.
Then we just have to tekan here.
Okay. Back. Here, back.
Start presenting.
Okay. Okay, yeah. So first of all, we check, yeah. Applications of electromagnet. Just now we already finished this. Okay, we go for the next. Okay. Okay, now we check. Later you want to screenshot, can, to save time, yeah. Okay. So first of all, we check electric bell. Okay, this is a sample diagram for electric bell, and you can see here we are using C-shape iron core. Can see, right, the C-shape. Okay, I hope you can see the C-shape. So what happened is current is flowing when the switch is closed. Okay, you can see over here, there's a switch, correct? Can see or not? I'm marking over here. Okay. Okay, so here got a switch. When the switch is turned on, okay, when you on the switch, current flow. Okay, let's check current flow. Where is it? So here is the direction where the current flow. Current flow through this springy metal strip, and then through the contact, through this wire, and flew to these coils, then come over here, then it is complete the circuit. Wang Yun. Wang Yunfeng, off your mic, please. Okay, thank you. Okay, So how to go back? Start from current slide. Okay, now okay, ready? So what happened is the current flow, remember, current flow from the positive terminal, then will flow throughout the circuit, through the contact, okay, through the contact to the soft iron core, the C-shaped soft iron core, then complete. Okay, then complete. Hey, wait, hold on, got problem here. How to change the others? The reverse cannot.
You can't see it only. You can't see the
Okay.
see the person.
Hold on, hold on.
Now I can change.
Enlarge this. What slide presentation? Okay. Then
Pencil. Edit pencil.
okay. Okay, thank you. Okay, so I show you again, yeah. I show you again. Okay, wait, I use a different color, green. So I have to choose, no choice. Okay, I choose red first, yeah, red. Okay, so here positive, here negative, yeah. So at first, when the switch is closed, what happens is current flow through this contact, yeah. There's a screw contact. Just give a contact like this. Contact. Here you got screw, right? So when it's in contact, current flow. But once it's moved back, let's say it comes to this, okay, over here. What happened? It will lost the contact. When lost contact, what happened? No current flow over here. So current flow through the contact to this coil, then come over here through this coil, and then it will complete circuit. So when current is flowing, okay, when current is flowing, what happens is the soft iron core become what? Electromagnet. When it is become electromagnet, what happens is it will pull the soft iron. Okay, so it will pull the soft iron armature. This is a soft iron armature. Okay, where? Okay. Oh wait. This is what we call soft iron armature. In BM we said kepingan teras besi lembut, soft iron core. So what happens is the soft iron core will be pulled, attracted. It will be attracted. Once it's being attracted, what happens is the soft iron armature is magnetized, and then it will attract the soft iron core is magnetized, and then it will attract the soft iron armature. Once this soft iron armature is being attracted, being pulled, what happens? The contact over here. The contact over here is what? Open. When the contact is open, okay, wait, once it's pulled, you can see over here, there is a hammer. So this hammer will go and strike the bell and produce what? Sound. So I repeat, when switch is on, current flow in the circuit cause the soft iron core become electromagnet, and then the soft iron armature being attracted. When attract, you can see the hammer will strike the bell. Okay, hammer will strike the bell, and then it produces what? Sound. But at the same time, remember, only once when it's full, hammer strike the bell and produces sound. But that time, what happened? The contact over here. Oh, battery gone. Okay. So at that time, what happened is this springy metal strip, it will move like this. When move, what happened? You can see over here, it lost the contact. When contact lost, what happened? Here, current zero, no current flow. When no current flow, what happened? The electromagnet lost its magnetism. It will lost its magnetism. No, okay, it's no more electromagnet. So what happened? Here, you can see the springy metal strip. Springy metal strip, it will pull back because it's elastic. It will pull back, yeah? Okay, it will pull back the springy metal, springy metal strip will pull back the iron armature back. When pull back, and then it will come to in contact again. When it is in contact over here, what happen? Current flow again, and then soft iron core is magnetized. Hammer strike the bell and produce the sound. Then the bell will ring continuously until you off the circuit. Okay, now I repeat again, one by one. Again, so first one, when the switch is pressed. I mean here, when the switch is pressed. Current flows in the circuit. Yes, current flow in the circuit. Good. Number two, the iron core is magnetized. Which one? This one. It is electromagnet. The iron core is magnetized. Become what? Electromagnet. Number three. What happened that time? The soft iron armature is attracted. Which one? Here. This is a soft iron armature. It is being attracted. When attract, that time, the hammer. Here the hammer. The hammer strikes the gong and rings the bell. Because it's what? Being attracted. When the soft iron armature pull, hammer also move together. Hammer also will move together and then rings the bell. The next is at that time, what happened is that when the hammer is moved, then here the contact will be open. When the contact open, no current can flow. No current can flow. No current can flow. When no current flow, what happened? The soft iron core will lose the magnetism. So the springy metal strip will pull back the armature to its original position. Okay. So the springy metal strip pulls back the armature to its original position. When pulled back, the process, then the contact will be close again. Here, close again. Then the springy metal strip pull back the armature to its original position, and then the process repeated, and the bell rings continuously. You don't worry about the process, the complete story. Don't worry about this. They will ask about the modification, and they already asked in SPM before. Okay, they already asked before. Wait, Okay, so I repeat once again because this maybe some of you confused. If can, later I will send you the video clip. I will send you a video clip regarding the electric bell. You go through that over there in terms of animation. Okay, because today got another 50 minutes. I have to finish all the application today, so that next week you can start with a new subtopic. Okay, I repeat. First one, when the switch is pressed, current flows. Second one, I mean here, yeah. That time what happened? The soft iron core become electromagnet. Number three, that time what happened? the armature, soft iron armature, is pulled by the electromagnet, then what happened? The hammer will strike the gong and rings the bell. Okay, then when it's moved, when the hammer move, right, what happened? The contact over here will be open. When contact open, it means what? No current flow. When no current flow, what happened? The springy metal strip is elastic. It is what? Elastic. So it will pull back the armature to its original position. When pull back, contact will be closed again. When contact closed, the process will be repeated because of current flow. Okay, because of current flow, the process repeated. Oh, wait. Okay, you want to screenshot? Can screenshot now. Can screenshot this. Okay, finish. Okay, now we move to the next one is electromagnetic relay. What happened? Oh, because of size. Yeah. Right. Electromagnetic relay. Okay, where you can see this. Okay, we will come back to this again when come to the chapter 4, electromagnetic relay, which will be used to activate a circuit that use high voltage. Okay, so for example, okay, you can see there is a two contacts over here. Two contacts over here. Yeah, at this region, you can see there's a two contacts. But the contacts over here is open. It's not closed. It's open. Okay, it is open. And then here is electric motor. Can see the electric motor. And then there is an output circuit. Okay, this is what? Okay, here is what? Output circuit. And let's say here we are using 240 volt. It's very high voltage. Very high voltage. So we cannot directly connect with the secondary circuit. This is a secondary circuit. This secondary circuit use what? High voltage. High voltage. And if you want to activate this secondary circuit separately, yeah, use a small current. That means you are using electromagnet. For example, let's say if in the car, right? If you're in the car, okay, you put the car key. Let's say this is okay. For example, Honda. Okay, for example, there got key. Yeah. Okay, car key. Got key here. Okay. Once you put the key, let's say the key is made of metal. Okay, and then it is directly connected to the high voltage. What happens? Then you will feel the electric shock, right? So cannot. We don't want this. So okay, that's why when you put the key over here, what happens is when then you turn, or that means what? If you switch on. When you switch on, what happens? Current flow. Okay, current flow in the coil. Then what happens? The soft iron core become what? Electromagnet. When it is become electromagnet, okay, when it is become electromagnet, what happened? The soft iron, this is what? This is soft iron armature. Kepingan teras besi lembut. Soft iron armature. And then here you can see there's a pivot. No need to explain anything about the pivot. Yeah, just holding the soft iron armature. So when you on the switch, small circuit, which is what? Small current. So what happened? The soft iron core will be magnetized, become electromagnet. Okay, become what? Electromagnet. When it is become electromagnet, what happened? The soft iron armature will be what? Pulled. When the soft iron armature is being pulled, when pulled, you can see the contact over here. Not contact. There's a pivot. So what happened? This one will move. Wait, I remove this first. What happened is the soft iron armature will be pulled. When pulled, then what happened here? This one will move upward, right? It will move upward. So what happened? This contact will be pushed. When the contact is pushed, what happened? The secondary circuit, here it is used what? 240 volt. Let's say, for example, 240 volt is high voltage. When the contact over here is closed, then the electric motor will be activated. For example, the motor, the engine of the car will be activated. But it's used what? High voltage. So it means here we are not direct contact with the secondary circuit which uses high voltage. So I repeat, when the switch is closed, current flow in the coil makes the soft iron core become electromagnet. Then the soft iron armature is being pulled. This is what? Soft iron armature being pulled. That time, the contact will be closed. Secondary circuit will be activated. So for your information, this one, the test in SPM, they ask the students to explain. So what you need to explain? Okay, you look at this. Number one, when the switch is pressed, current flows. 1 mark given for this. Okay, when switch is pressed, current flow. 1 mark. Then next one is soft iron armature become electromagnet. Or you can write soft iron armature is magnetized. Okay, soft iron core is magnetized or become electromagnet. Okay, soft iron core become electromagnet. Okay, soft iron core become electromagnet. Then the soft iron armature, which one? The soft iron armature. Okay, this one. I already label over there. Soft iron. Wait, I remove the what? Wait, I remove the fans. Okay. The soft iron armature, which one is it? Karinesh, off your mic, please. Karinesh, off your mic. Thank you. Okay, this is a soft iron armature. Soft iron armature will be pulled by the electromagnet. This is the electromagnet. Yeah. Okay. So when pulled, what happens? The contact will be closed. Contact switch is closed. Don't write anything about the pivot. Yeah. Okay, this is the pivot. Don't write anything about the pivot. Okay. So contact switch is closed. When the contact switch is closed, what happened? The power supply in the secondary circuit or output circuit is switched on. The power supply in the secondary circuit or output circuit is switched on. Finish. That's all. Finish. 4 marks given. What 4 marks? Okay. What for you give? 4 marks. Number 1, number 2, number 3, number 4. That's all. Number 5 is extra one. So please screenshot this. Sorry. Screenshot this. Wait. I need to make it smaller. Wait. Can see, yeah? Okay, yeah? Can? Okay. Now, a screenshot. I repeat very fast. Okay, first point. Oh, sorry. First point, remember, switch is closed, current flows. Correct? Switch is closed, current flows. Wait. Wait. I think someone is waiting outside there. Wait. If I use my iPad, then you cannot see. Wait. Okay. Hey. Start. Okay, so electromagnetic relay is very simple. It's a small circuit that uses a small current. It will be used to activate secondary circuit which uses high voltage. So first one, when input switch is pressed, current flows. Clear. Number two, what happens? Soft iron core become electromagnet. Clear. Number three, soft iron armature is being attracted by the electromagnet. It means what? It's being pulled. Number four, the contact switch is what? Closed. Then number five, the contact, okay, power supply in the secondary circuit is switched on. Finish. Finish it. So electromagnetic relay, finish. Okay, now we go for the next one is, okay, finish. This is another one, same like just now. So no need to worry. Okay, finish already. This one finish. This one that I already explained just now. Okay. We come to the next one is telephone earpiece. Okay, telephone earpiece. Okay, for the telephone earpiece, there's two stories over here. Subtopic 3 and subtopic 1 combined. Okay, okay. This one earpiece, and one more is the microphone, mic. When you're talking using phone, okay, the place where you're talking is like they're using mic, and then the sound that produce, I mean, you're using, yeah, it will be converted into electrical energy. That is the one that will be sent to the receiver. Here, the receiver. The current that flow over here is what? It's a varying current. That means the current increase and then will decrease. Increase, decrease. It will increase and decrease. That means it is a varying current. Means in BM we said arus yang berubah-ubah nilai dia. Okay, the current flow is what? Varying current. So the current that flow over here is what? Current from the microphone. Yeah, microphone is a varying current. And then when the varying current flow in the soft iron core, what happens is the soft iron core become electromagnet. Which one? Here, you can see the solenoid. Solenoid. Okay, it will be, can see or not? Can see or not? Can see the,
Can, sir.
can,
Cancer.
Okay, thank you. So you can see the solenoid. So when the current flowing is a varying current. I mean, in BM said arus yang berubah-ubah nilai dia. Yeah. Okay. So when the varying current flow, what happened? The electromagnet over here. The strength of electromagnet is what? Varying. Becomes strong electromagnet and then getting weaker. Strong electromagnet and then what? Getting weaker. Okay. So the strength of electromagnet varies. And here you can see there is a diaphragm which is made of alloy. Alloy diaphragm. Alloy, yeah? Alloy diaphragm, it is made of metal. What happens is this alloy diaphragm will be pulled. Will be pulled by the electromagnet with a varying force. Okay, let's say this is a diaphragm. So this diaphragm will be pulled. Will be pulled and then released. When it is being pulled with a greater force by the electromagnet, it will be displaced more. Okay, vibrate more, vibrate more. When more current flow, it will pull with a greater force. It causes what? The diaphragm will vibrate in and out. In and out, it will vibrate. Like if you take a drum, if you hit the drum, what happens? The surface of drum will vibrate. Vibrate, and then it causes what? Air molecules here compress, rarefaction. Okay, compress and rarefaction. So it produces a series of compression, rarefaction, the air molecules over here. Correct? So that's why we can hear the sound. Okay, so if you check, don't worry about the working principle. They won't ask about the working principle. Simple one is varying current from the incoming signal flows through the electromagnet. Wait. Good morning, sir. Accidentally left out. Wait, remind. Okay. So when varying current from the incoming signal flows through the electromagnet, next one, this makes a Lloyd diaphragm vibrate and send the sound wave into our ear. I mean the Lloyd diaphragm. You can see the Lloyd diaphragm over here. It vibrates in and out. Okay, it will vibrate in and out and then send the sound wave into our ear. Simple. That's all. Very simple. Okay, so you can screenshot if you want. Faster. I repeat, when the varying current flow in the coil, it makes a soft iron core become an electromagnet, where the strength of electromagnet is rise because the current is rise. So this makes a Lloyd diaphragm will pull and then it will vibrate and then send the sound wave into our here. Simple finish. That means here we are using what? Soft iron core. Okay, soft iron core. Okay, the next one is circuit breaker. We finish off first. Circuit breaker. Where you can see this circuit breaker? In the automatic switch. Okay, in the automatic switch. Okay, so let's say here you connect. Wait, hold on, wait.
5 minutes to do it.
Hold on, 10 seconds. Sorry, 30 seconds. Wait for a while. Wait, hold on. Give me another 5 minutes there so that I can finish off this subtopic. So that next week we discuss and then we can start with the subtopic number 2. Okay. I think. Okay, enough. Okay, so let's say here we connect to the household electrical appliances. For example, let's say television, refrigerator, iron box, and so on. So when and then in the normal condition there is a current flow. In normal condition, current flow, small current flow. When small current flow in this thin wire. Okay, and then here is a contact. Yeah, contact. What happens is current flow in the coil, and then this is what? Soft iron core. This is soft iron core, and this soft iron core will be magnetized. It will be magnetized. Yeah, become electromagnet. So when it's become electromagnet, this is what? This is soft iron armature. Okay, soft iron armature. Kepingan keras besi lembut. Besi, that means what? It can be attracted by magnet. And then here you can see there is a contact. It is already locked. This wire, it is already locked over here. Locked. Okay, it's already locked. That means cannot release. So now, when the current flow in the solenoid, it makes the soft iron core become electromagnet. When become electromagnet, what happens is the soft iron armature is being pulled. When it is being pulled, what happens? When it's being pulled, let's say like this, it comes like this. When it's being pulled, okay, pull, then the thin wire over here will move like this. It will move upward. I mean, it's no more ready. It's no more in contact. Contact over here will be open. When contact open, no current flow. No current flow. When no current flow, what happens? That means the electrical appliance is not functioning. This process only takes place when suddenly the current over here becomes very high. Very high. So the soft iron core becomes strong electromagnet and then we'll pull the soft iron armature with a greater force. Then when pulled, the contact will be open. When the contact is open, current circuit is not disconnected. The circuit is disconnected. Then how you're going to connect again? So let's say the wire over here is already moved until here, right? Contact is here, and then this, okay, this armature is here. The armature is here. So what you need to do is you have to use a reset button, push. Okay, push using the reset button. Once you push, what happens? This contact will be pushed down. When pushed down, the contact will be closed. Closed, then current will flow again. Then the electrical appliance start to function. Okay, so they mean, for example, let's say during the lightning, when the current flow is become very high, suddenly become high, the circuit will be disconnected from the excessive current, so we can protect the electrical appliance from the excessive current. Okay, so let's check the explanation here. So a circuit breaker is an automatic switch. Later, I will send some video clip into the group. Okay, after my, tomorrow, sorry, not today. Oh, no, later I send you, never mind. I will send some video clip for the all these applications. You just watch. You can get the idea. Don't worry. Okay, so a circuit breaker is an automatic switch which cuts off the current in the circuit when it becomes excessive. This one, keyword. When the current becomes too high, then only become what? Strong electromagnet, so that it can release the iron cache. Here. Okay, it is in contact, it's already locked. But when pulled with a greater force, the contact will be what? Open. Okay. In the type shown, the current flows through the two contacts and also through the electromagnet. I mean, current flow through this contact and also the electromagnet. If the current is too large, okay, if the current is too large, wait. Okay, if the current is too large, okay, where is it? It's shown to, okay. If the current is too large, the pull of the electromagnet become very strong. I mean the force. The force active is very strong. Pull of the electromagnet is very strong enough to release the iron cache. Which one? Here. To release the iron cache. So that the contact open. The contact is open and stop the flow of current. By pressing the reset button. This is a reset button. By pressing the reset button downward, so that we can close the contact again, so that current can flow again. That's why during the lightning, you can see the main switch is off automatically. Then you will on again. That means the automatic switch over here will protect the electrical appliance from what? Excessive current. Okay, clear? Clear? Okay. So wait, wait. Finished already. We already finished the chapter. Okay, now what I want you to do is, okay, I want you to answer all the questions in the module. Okay, I want you to answer all these questions. Yeah? You must answer, so that next week we can discuss these questions. Answer all these questions. Answer all. No excuse. Answer all, and then please skip question number 3. Number 3, don't answer. I will discuss this on next week. Then only continue with the subtopic 2. Okay, they won't teach this in a school. Number 3, yeah, the diagram number 10.3, they won't teach. I will teach next week over here. Okay, number 3, don't answer. Number 4, you can answer. Okay, so and you can see in the module on page 10 and also 11, I will give you the 2 sample report that you already copied just now. So same. Yeah. So I want you to answer all the questions except the question number 3. So see you on next week. So make sure that you solve all these exercises. Okay, thank you very much. Bye. So only for subtopic 2, 3. Oh, wait. Don't leave. Wait. Please go to the chat box and then please type your name and also the name of tuition center. Then only leave. And one more is please make the Okay, one more is for the June payment, please settle as soon as possible. The clerk asked me to remind you all. Yeah. Okay, please type your name and then can exit the group. Thank you.
Thank you, sir.
Welcome.
Thank you. Bye bye.
就是
造狼啊！
谢谢。